Welcome to our second lesson on calculus. In this particular lesson, we're going to talk about rate of change. Now, when we are referring to rate of change, we need to make sure we understand the concept as it's the essence of calculus. As you guys all may already know, rate of change is another way of saying slope. And when we are calculating the slope, we could calculate it through average rate of change, which I will be referring to as AROC, through the course of the time. And AROC is calculating the rate of change between 2 points on the graph. The formula is over here, so you guys could jot it down. And the next type of slope that we're going to look at is instantaneous rate of change. Instantaneous rate of change is calculating the slope at one particular point on the graph. And as you could see, the formula is over there. Now, just a refresher, because it's been a while since we talked about this. Parallel lines are when we have two lines that will never meet. And if these two lines never meet, it means that the slopes have to be the same. Whereas with perpendicular lines, these are two lines that meet, but they meet at a 90 degree, which then results to the slopes being negative reciprocal of each other. Review the Pascal triangle with you guys. So with the Pascal triangle, we start off with 1, and then the corners are going to be 1, okay? And as we get bigger and bigger, the sum of these two will be our middle term. So what's 1 plus 1?
2.
Then we have the corners here. We get the sum of this, and then we also get the sum of that. So what's 1 plus 2?
3.
What's 2 plus 1?
3.
Just gonna go one more. 1 plus 3?
4.
3 plus 3?
6.
3 plus 1?
4.
So right now, over here, we have this triangle, but what does this triangle mean? By the way, do you guys see the triangle?
Yeah.
Jazz, do you see the triangle?
Yeah.
Okay. So now this means that this is a plus b to the power of 0, which will be 1. The next one is going to be a plus b to the power of 1. You see these numbers here? These are going to be the coefficients. So it's going to be 1, a to the power of 1, b to the power of 0, plus 1, a to the power of 0, b to the power of 1, which we could simplify to just a plus b. So far, so good?
Yeah.
The next one is going to be a plus b to the power of 2, which is 1, a to the power of 2, b to the power of 0, plus 2, a to the power of 1, b to the power of 1, plus 1, a to the power of 0, b to the power of 2, which we could simplify to a square plus 2ab plus b squared.
Okay.
And then the next one is going to be a plus b to the power of 3, which is 1, a to the power of 3, b to the power of 0, plus 3, a to the power of 2, b to the power of 1, plus 3 again, a to the power of 1, b to the power of 2, plus 1, a to the power of 0, b to the power of 3, which gets simplified to a cubed plus 3a squared b plus 3ad squared plus b cubed.
Okay.
And then The next one that we have is a plus b to the power of 4. Do you guys understand this step over here?
Uh,
Do you understand what's happening?
the same thing you're doing with the rest, right?
Yeah. So all of these steps over here, do you guys understand what's happening?
Kinda.
I'm kind of lost to that part.
Okay. So do you see the exponent that we have over here?
Yeah.
So we start off the first term. Okay. We start off the first term, which is a with that exponent, okay? And the second term always starts off with an exponent of 0. And each time the first term is losing an exponent and the second term is gaining an exponent. Do you guys see that or no?
Could you explain that again?
So let's say we had a plus b to the power of 4, or let's say even something bigger. Let's say to the power of 7. We're going to have the coefficient over here based on the Pascal's triangle. The exponent of a is going to be 7. The exponent of b is going to be 0. Okay?
Okay.
And then for the next one, a is going to lose an exponent. So what's 7 minus 1?
6.
Okay? And b is going to gain a exponent. So what's 0 plus 1?
1.
Good. So what would be the exponent for the second one, Jazz? Jazz, can you hear me?
Yeah.
Okay, so what would be the exponent for the next one? A to the power of?
0.
No, it's losing an...
7.
Nope, a is losing an exponent. So the one before was 6. So what's 6 minus 1?
5.
Yeah, and then b is gaining an exponent. So what would it be?
2.
Good. Maureen, the next one. What's going to be the exponent of a?
A to the power of 4.
Good. And b to the power of?
3.
Yep. The next one. Jazz.
A3, B4.
Good. Next one, Maureen.
A to B5.
Good. Next one, Jazz.
A1, B6.
Good. And Maureen, the last one.
It'll just be A, B, 7.
A to the power of 0, b to the power of 7. So what you should notice is the first term starts off with 7 as its exponent, and the very last term has our second term, which is b to the power of 7.
So this just keeps going until A is to the power of 0?
That's right. And b is to the power of whatever this exponent here is.
Okay.
Okay? Good?
Could you scroll up so I can write it down? Yeah.
So now let's look at this one. It's going to be 1, a to the power of 4, b to the power of 0, plus 4, a to the power of 3, b to the power of 1, plus 6, a to the power of 2, b to the power of 2, plus 4a to the power of 1 b to the power of 3, and then plus 1 a to the power of 0 b to the power of 4. So if I were to simplify this, it looks like a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to the power of 4. Do you guys have any questions?
No.
No? Okay. So you guys understand this, right?
Yeah.
Okay. So I'll give you guys some time to take note of this. To recap, in advanced functions, we did IROC, which means instantaneous rate of change, is equal to f of x plus 0.001 minus f of x over 0.001, right? In advanced functions, the very first thing that we're going to do is use limits. So it's limit h tends to 0, f of h plus, f of x plus h minus f of x over h. So as you could see, the two equations are very similar, right?
So for the limit, is it basically the same thing, but it could be a different value, or?
No, so I'll explain that after. But over here, do you see how it's very similar?
Yeah.
The only thing that's different is that 0.001 got changed with the h.
Okay.
So right now, we're not going to get into limits as of yet, okay? But what we are going to do is figure out, well, how do we go from f of x to f of x plus h, okay?
Okay.
So when we are doing this, let's say we have f of x is equal to 3x plus 7, then f of x plus h is going to be 3x plus h plus 7, which results to 3x plus 3h plus 7.
Okay.
Any questions with this?
No.
So this one's easy, right? Jazz, is this one easy? Are you there, Jazz?
Yeah.
Yeah? Okay.
Yeah.
You need to come in earlier. And then let's say we had another example that was f of x equals x squared minus 1. This one looks a little bit more complicated. So over here, what we're going to do is plug in f of x plus h. So this value will get substituted in with that value. And now we would need to use FOILing in order to simplify this. So we know that this falls under the perfect squares. So what we would do is x squared plus 2xh plus h squared minus 1. And over here, we can't really simplify anything. So we're going to leave it the way that it is.
Okay.
Okay. Now, before we go into any numbers that are bigger, I'm going to review the Pascal triangle with you guys. So with the Pascal triangle, we start off with 1. And then the corners are going to be 1, okay? Example, where it was f of x equals 3x cubed plus 1, okay? And what I'm trying to do is figure out what is f of x plus h. So I do 3x plus h to the power of 3 plus 1. So now, for this question over here, I just need to look at this part over here and apply that rule, okay? So then this becomes 3x to the power of 3 plus 3x squared h plus 3xh squared plus h cubed plus 1. When I simplify this, I get 3x cubed plus 9x squared h plus 9xh squared plus 3h cubed plus 1. I'm going to see if I could collect any like terms, but by the looks of it, there are no like terms for me to collect. So I'm just going to leave it like this over here.
Could you explain it again? I don't get how you got the the third one. The
Like
third
this.
one. Yeah.
So if we look at it, it's this one here, right? So this is going to be x to the power of x to the power of 3, h to the power of 0, plus 3, x to the power of 2, h to the power of 1, plus 3, x to the power of 1, h to the power of 2, plus 1, x to the power of 0, h to the power of 3. And then we simplify it and it would look like this over here.
So this triangle goes for like all the equations?
It's only when it's perfect, like it's only when it's written in this form here. Do you see it?
And how did we know it was that specific line?
Because the exponent is a 3.
In the equation?
Yes.
Oh, okay. Or can't we just skip that step and go straight to the simplified version of the Pascal ones?
Yep, you can. So this is something that you should have learned in grade 11. So grade 11 goes over Pascal's triangle. So now you're just applying it in grade 12. Well, you applied it in grade 11 as well, but you're just also reusing that same concept again.
Okay, let me just write down the triangle.
Why don't you just take a screenshot of this?
Okay, yeah. Alright, I took it.
Okay. So you guys understand this concept over here? Okay. So we learned that this is how you apply limit, right? So what you should do is, let's say you were given f of x equals 1 over x. You have limit h tends to 0, f of x plus h minus f of x over h. Now, this part over here, I'm going to do on the side. So we have f of x plus h, which equals 1 over